Yeah, good afternoon, students. It is my pleasure to introduce this CDT on implementation of the stack operations using single linked list. So now I would like to share my screen. Hope my screen is visible to you. So this is the CDT 29 Week 10 lecture to stack operations using linked list. So the summary of the previous CDT is that we discussed about the skip list in the previous CDT. So skip list is nothing but it is used to store the sorted list of elements with the linked list, and we are using this skip list so that we can perform the search operation more quickly. So it allows the process of the elements or data to be searched efficiently. In one single step, it skips several elements of the entire list, which is the reason why it is called as a skip list. So skip list structure will be maintained in two layers, the lowest layer and the top layer. The lowest layer will consisting of express the lowest layer is consisting of the normal sorted linked list will be there, and the top layer which is consisting of the most important elements. Based on that, we can skip certain elements in the search process. So now the today's session objectives is that the implementation of stack operations using linked list. The lecture outcome is that upon completion of this PDT, students will able to write the code for implementation of stack operations using linked list. So now you take this program here basically. So we have this node structure similar to that single linked list node. Here we can define int data or info struct node star ptr, and then here we are taking start top and start top one and start temp. Here top element we want to return, and push and pop are the methods. Empty is the another method to know that whether the linked list is empty. So there is no full link stack is full like that. The condition will not be there, and this is a display and destroy function, and this is a count function. So now create. So this is the menu which we are creating, that push pop top empty exit and display. So how many elements are there in the stack count, and then destroy stack. So that we are calling here. Then after that we are calling the options. Based on that option, we are calling the respective function. So enter data. If case 1 enter data, we are reading the data, and then we are passing the data to the push function. So case 2, then we are popping the element, and the case 3, if top is equal to null, case 3 is nothing but top, to print the topmost element. If top is equal to null, no element in the stack. Else we are popping that element into e top element. We are calling that function, and top element is we are displaying that. So case 4 empty, we are calling that. Case 5 simply exit. Case 6 is display. Case 7 is what we are calling it as count. Okay, so this is what we are calling it as here. Void create top is equal to null initially. So stack count, it will count number of elements. Okay, so count is a variable which is used to keep track of that. Now this is the push data. We are pushing the data here. Top equal to null, then top is equal to, we are creating the node, and top arrow pointer is equal to none. Top arrow info is equal to data. Else if top is not equal to null, that means there are some nodes already in the stack. Then we are creating the temp node, and then temp arrow pointer is equal to top. Top arrow info equal to data. Top is equal to temp. So count plus plus. So like this, when we are pushing that elements, we are counting these nodes also. Then this is what display stack elements you want to display that. So top equal to top one is equal to top. If top one is equal to null, stack is empty, written. While top one not equal to null, then we are printing top one arrow info, then top one equal to top one arrow ptr. This is just like single linked list traversal operation only. Okay, there is nothing more than that. So this is inserting the node at front is nothing but push, and display is nothing but normal traversal operation of single linked list. So pop is nothing but just, it is nothing but deleting an element from the front. So top one is equal to top one is null, then trying to pop from the empty stack return. Else top one equal to top one minus ptr, top one equal to top one arrow ptr. Then popped element is we are just printing, and then we are freeing the top, and then top equal to top one, count minus minus. So this is the topmost element. If you want to return that, simply it will return the topmost element. This is empty. If topic only stack is empty, otherwise stack is not empty. This is what if you want to destroy the entire stack, the destroy function can be used. So this is what the code is basically. So to implement all the operations related to the stack, main operations are push, pop, and display. These are the three important main operations related to the stack that we have to implement using single linked list operations. Fine. So this is the reflection spot. So what are the operations of a stack? So already we know that. Okay. So push, pop, and is empty. If you are not able to understand this, please watch this video from the beginning. So lecture outcomes are revisited here. After completion of the session, students will be able to implement the various operations of the stack using linked list. So summary of the session is that linked list can be used to implement operations of the stack as well as queue operations also we can implement. Push operation is similar to the insert to front, and delete pop operation is similar to delete front. And the display is nothing but traversal operation. Fine. So this is what the summary of this today's session is basically. So there is no stack full condition here because it is a linked list implementation. So there is no fullness, but only we can check empty whether stack is empty or not. If top is null, stack is empty. Otherwise, you can go on insert the elements, push the elements, or you can go on pop the elements until stack becomes empty. So there is no stack full condition for this linked list implementation of this stack. Fine. So this is a lecture level practice problem. Write the program to implement two operations using linked list. Fine. So single linked list operations, you all familiar with that. So front, insert, delete front, and insert rear. Both are two important operations. You can fix for few operations. Fine. So this is further readings on this particular topic. You can refer that. So thank you, and all.